Hello and welcome to this tutorial where I'll be talking about how communication between processes, all developed in BPMN, can be modeled. Specifically, we're going to take a single process, we're going to talk through it, and then we're going to talk about how to model the other processes it interacts with. We're going to talk about some concepts around BPMN message events, signal events, and also how to model message flow in general. And we're going to start off by discussing this little model here, which is about ordering coffee, and then we're going to expand that to the other processes, creating a true end-to-end process that crosses multiple boundaries of ownership and design. So let's get started. Now, the best way to talk through a process or explain how a process works is by using the token simulation. On the web modeler, if you're using it, it's there by default. There's also a plugin for the desktop modeler. You can go find and install. So let's talk through this. Let's add some breakpoints and let's just discuss some of the things that happen here. First thing is that an order comes in. This is a pool representing a cashier, so they take an order. So an order comes in, they take the money for that order, and then that order might have coffee or baked goods or both or one or the other, right? And then we send the order to the barista. The barista then gets the order and we wait for a response. Meanwhile, the cashier actually goes and gets the baked goods, if there are any. And once they do, they basically get those and then wait for the barista to finish the coffee. The coffee eventually then shows up and we leave those items on the counter and subsequently call out the name of the customer to let them know that their order is ready. Then we just go to waiting. We're waiting for one of two things. Either it's been 5 minutes, in which case we go back around and then we call out the customer's name again, and then start waiting again. Or the customer does show up, in which case we take their order and the process ends. There's another sort of interesting aspect to this process, which is it's also possible that at some stage, when we go to get the baked goods, we realize there's none left, in which case we trigger this escalation event. Now this escalation event is then going to trigger this, which is going to trigger the refund of the customer. So the customer is refunded for the baked goods that they can't have. Meanwhile, the rest of the process continues as normal and they still get their coffee, which is quite nice. We also have a message send event here, which basically lets the manager know, hey, you should make more baked goods because we're out. Okay, and that's how we're going to that's how this process does. Now, what we're going to do now is talk about the other processes that are involved in this and then build those out. We're going to talk about some best practices on how to do that, but let's start by discussing what other processes, entities, actions, people are involved in this process outside of the scope of just the cashier. Now, the most obvious way to find out about that is just to look at where the messages are coming and going. That's how you know what other systems might be out there. Message events like this send one and this receive one, this send one, they always come from outside of the scope of the process. So that means that these are coming from somewhere else. And in this case, this starts with a process that comes from somewhere. A message that comes from somewhere, specifically a message event. So we are going to say customer. The likely person to create an order would be a customer. So I'm going to create what's called a collapsed pool. For now, we don't really know what happens with the customer. We just know that they do send us a message. Now, this is a nice way to start modeling because now we're just going to define the customer and we're going to think about all the ways that the customer communicates with the process. So the first way is obviously it sends something here. We then have, if we go through the process, we have call a customer's name. So let's expand this. So this is a message we send to the customer. Great. And then eventually the customer then gives us the okay that they have their order. Okay. There's also this refund. We'll talk about that a little later on. But for now, we'll just keep things a little simple and say this is our customer pool. And this is how it communicates with the cashier. So what else do we communicate with? Well, the next one is quite obvious. It's the send and receive from the barista. And that's quite interesting because you might not have noticed this, but this is a multi-instance. A multi-instance means that we're sending multiple orders, potentially multiple requests for one order. So it might be saying something like, this one order is for 5 coffees, so you send 5 individual coffee orders, or you're requesting those 5 coffees, and then you get a response when all 5 are made, right? Because we don't want to continue unless the order is complete. So how do we model that? Well, again, we're going to add a pool, and we're going to turn it into a nice collapse pool. And now what we're going to do is we're going to call this the barista, or whatever word that is. Let's try that one more time. I'm going to call that barista. Great. And the barista is going to have this lovely symbol here, which is the multi-instance. So this means that this pool can be called multiple times potentially, which means this pool is going to act on one individual coffee order, but can be triggered multiple times when we send this. Okay, cool. And also it needs to respond. So we'll have a response there. Let's make that a little bit like this. There we go. Okay, so that's our next pool that we have. And the final one is pretty easy. It's got this thing here. It's the order for more baked goods because we've run out. So for that, I'm just going to pop this over here and let's change that. Let's just call that the store manager. So then we can connect those two by selecting this and then moving that there. So what we have now is a model that shows us the other pools and how they're related. And a lot of people can stop right here and think, that's great, that's all the information I need to know. All I'm interested in is what this process does to communicate with others. And this is a perfectly reasonable model. But if you're interested in modeling like every participant as part of an end-to-end process, you're going to have multiple pools and you may want to define what's inside those pools specifically. So next up, that's what we're going to do. Predictably enough, we are going to start with the customer. I'm going to start by expanding this pool. Now, the expanded pool means I'm going to be able to add some elements inside it, and which is good because that's what we want to do. We also want to make sure that these message flows, this outgoing, incoming, and outgoing again, are going to be linked to a specific event or task inside of the process. So we have the communication mapped. So let's talk about how we would do that. A very important thing to do, it's always important, but especially important when you're modeling a process landscape or multiple processes, is after you create your start event, which is customer walks into a cafe. Oh, here we go. We want the end event next. The reason is for context and for scope. The very last thing we want to do is we want to make sure that we know when the customer process is done before we start modeling. The reason for that is because we want to have to make sure that every single pool in this landscape has a defined scope so that we don't go over scope or double modeling things that are modeled by other processes, and we define the ownership of what each process owns. In this case, this process owns when the customer or leaves, stops running when the customer has their order. Now this isn't the only end event, but this is the happy path. This is where we want the customer to go. So once they walk into that cafe, we're going to have a nice little user task here. And this is going to, let's say, decide on order. And right after that, we're going to have a message event. And this is a message throw. And this is going to say, send order to cashier. Great. And this is where we can connect our very, very first message flow. So let's grab this and let's put it here. Great. And another, this gives you the opportunity to talk a little bit about the difference between a send task and a send event. So this is a send task and this is a send. So this is a send event. This is a send task. And the differences are fundamentally not very much on an execution level, as in they send the same kind of message. They basically work in the same way semantically. The difference is in what you might want to accomplish, right? So let me explain why I've used one here and this one here. By default, always use send events and receive events, right? They're a single function event. The thing is, this is not single function. If you look at this, this has a multi-instance, right? Which means it can send multiple messages. And I can't actually do that with an event. I can only do that with a task. So generally speaking, if you need to do more than just send a message within a certain scope, then use a task. But if you're just sending a message and that's all that's happening, use an event. And most people by default should use events. So next up, I'm actually going to add a receive. I'm going to add a receive task here, and I'll explain why. So a receive task is going to get back our order. So this is going to be wait for order to be ready. and we can connect this, right? But of course, it's very, very important to remember that while waiting for your order, I'm not sure if you've done this, but it's very possible that you get kind of bored, and I know I do. So if you do, we need to like model that in some way. Specifically, I'm going to add a boundary event. Another reason to use a task or rather than an event is if you're using a boundary. So here we're waiting for this order. We also have a timer event where if we, let's say after 1 minute, after a minute, we are going to go and check our phone. Check phone. And once we're done with checking our phone, we will go back to waiting. And I'm going to use a merging gateway here to merge the flow back. Okay, there we go. So we decided in our order, we send it to the cashier, then we start waiting. But if we're waiting too long, we'll go check our phone, and then we will go back to waiting again. Then once our order is ready, we are then going to, let's say, collect our coffee. So I can use an event for that. Receive event. Sorry, send event. And this is going to be collect coffee. So this is more of a confirmation, and we're going to just take this here. There we go. And then the process happily ends. There we go. And the customer is in good shape about that. So let's see how this looks with token simulation. As we discussed, the process begins when the customer walks into the bar or the cafe. So we're going to do that. They decide their order, probably something very fancy, and then they send that order to the cashier. Then they start waiting. And you can see here that they're waiting. Meanwhile, their money has been taken, and we then have two processes running in parallel. While the customer waits, they may actually check their phone a couple of times, and then go back around. Meanwhile, the barista is doing their thing and making their coffee, and the baked goods are being taken up. Eventually, of course, we are going to leave stuff on the counter and then call out the name for the customer. But the customer isn't there, so we are going to go back around and now start waiting, which is a great time to explain why it's so important that we have this little 5-minute delay before response. Because now we have realized that it's possible to model asynchronous communication, meaning that I can send a message and need to wait for a response, but what if I don't get that response? Well, now I'm able to shout again at the customer saying, hey, you should do your thing. This message now gets triggered, and now this message event comes down, and we are good to go. And that's how the customer is going to get their stuff. So we're looking pretty good so far. So let's look at the other processes. And now into everyone's favorite time in the morning. It is coffee time. So let's roll down here to the barista. Let's put the store manager in the corner for a while. And let's do the same thing as before. We are going to expand this into a pool, and we're going to work out how we're going to model this barista. So the first thing to remember is we have a pool now that we're going to add stuff to, and we have two message flows coming, one coming in, one coming out. So it's pretty clear that this starts from a message event, because once an order comes in, we're starting the process. So let's change this to a message start event, and this is going to be order comes in. Okay, now, very important question for those paying attention. What is the next thing that I model? Oh, wait. Some of you got that correct, I assume. The next thing is, of course, the end event, because we're defining the scope of this process. The end event is going to be that I'm going to put it over here, and it's going to be the coffee has been delivered or created or made. There we go. Cool. So we'll get to that in the end. Let's talk through the happy path of this. So the first thing we do is, like any good coffee place, we are going to grind some beans. Grind some beans. Tasty. And next we are going to, depending on the order, we might need milk or we might not. So I'm going to use an OR gateway, similar to what we, inclusive gateway, similar to here, where I'm going to, in some cases, I'm going to make some milk. So steam some milk. And in all cases, though, I am going to pour the coffee, because even stuff without milk needs coffee. So how do we define that? So what we do is we're actually going to say that we're going to say always. So this is we're always going to go this path, and this is going to be needs milk. So this is a sometimes path. Now this is always a nice way of showing an alternative route through your process. You have your route you'll always go and your route you sometimes go to, and we'll just connect those and match up the gateways, and we are good to go. Okay, and then last we are going to add coffee to cup. So now we have a cup, great, and the coffee has been made, which means we are going to change this to an end event and connect that here. So now our coffee can go back up here. So there's some other stuff that's important that we're going to add now, which is the least type path. Let's just pour this. It's probably not going to be too difficult, so let's turn this. There we go. So the next thing is, what if there are no beans? Well, this is pretty bad. In fact, I'd go as far as saying this is an absolute disaster. And those eagle-eyed people from the very beginning may have noticed that I never talked about this thing here. This is an event that is called a signal event, and unlike a message, this thing here I'm talking about, this is a broadcast. So you don't actually map them directly, right? So this may happen at any time because it's in an event sub-process, but it's waiting for a signal that has to shut the shop down, and then this will trigger any refunds for anybody who is still waiting for their coffee, and then if not, then then the coffee shop will close. So how is this triggered? Well, clearly this is a coffee shop. So if we if we find that we cannot grind beans because there are no more beans left, we're going to throw a BPMN error event. So no more beans. Great. And then we're going to, of course, send a message to the manager. Order more beans. Great. And finally, we are going to send that signal event as an end event. And this is going to be a signal. And this is going to be close down coffee shop. Close down shop. Because we've decided without coffee, what's the point? So then we're going to send this message over to the store manager. There we go. Okay, so the next thing we're going to do is we're going to make sure that we have no loose ends. Now there's one very clear one, which is that once we throw this event, right, it means there'll be no more coffee orders because we've basically told the cashier to close down the shop. So there'll be no cashier. The problem is that the potential, there could be still customers doing stuff. So we have to get rid of them as well. And the nice thing about signal events is that signal events, because they're a broadcast, can have multiple recipients. So as soon as there's no coffee, we're basically going to close down the shop. The barista goes home, the customer goes home, and of course the lovely people in the coffee shop also go home. So there we go. We have a solution there, all as well. And let's see how that looks if we use token simulation. And let's start where we always start, which is of course with our customer ordering coffee. And we see here that we ordered the coffee. Great. We're waiting for our order. We've taken the money. Let's go forward. We are now going to trigger the send event here, which is going to start our process. We're going to grind some beans. We're going to have some steamed milk and some coffee. Great stuff. They're both there. We add it to the order, and then we go up here and we trigger this. Great. Meanwhile, the baked goods have been taken. Fantastic. We've left those on the counter. I'm going to pass that along to our customer. We're then going to call out their name. They are then going to, of course, say, yes, that is mine, and they're going to get their coffee back. And our process ends. Everyone gets coffee and everyone is happy. So I hope you enjoyed that. There are some things for you to do though, because I thought, why would I do all the work when I have people watching this, enjoying this, and could help me out? So the first thing is, if you're interested in learning more about this, think about ways in which you would implement this, the refund. How exactly would you implement a refund between the customer and the cashier? The model is available on GitHub. You can download it and put it in the modeler and then add your changes, and then let me know what kind of changes you suggest. Another thing you can do is flesh out this process here. We never actually expanded on it. It might be worth expanding it. See what you can do in there to make the store manager a more integral part of the process. And of course, if you want, you can spot any little lingering doubts you may have with the actual process. There are one or two things that are a bit sort of iffy about it, but it's up to you to try and find those out and suggest some changes. So I hope this is a fun experience for you. Hope you learned a little bit, and I hope you now know a little bit about process communication. Cheerio.